1,000 students, 5 years, 6 different engineering courses. What would you learn if you could track every single quiz question, every moment of engagement, every pattern of success and struggle across that massive scale? The answer might surprise you, because it's not about being the fastest. But it's not about getting every answer right either. I'm Meira, and this is Kahoot Impact, the podcast where we take fascinating education research and translate it into insights you can actually use. Today, we're diving into 2 groundbreaking studies that reveal something powerful about how students learn. One tracked over 1,000 engineering students across 5 academic years. The other synthesized data from 43 independent research studies spanning 16 countries and more than 3,300 students. And what they found challenges a lot of our assumptions about what actually drives academic success. But before we get into the research, I want to let you know, if you're listening to this and you'll be at the BET conference in London from January 21st to 23rd at the Excel Arena, come find us. I'd love to meet you, hear your questions, and learn about the challenges you're facing in your classroom or institution. I will be recording snippets for future episodes too, so you might even end up on the show. All right, let's start with a question. Think about your own experience as a student. Or if you're an educator, think about your students. What predicts success? Is it natural talent, prior knowledge, how quickly someone can answer a question? Think about how we measure mastery, time multiplication tests in elementary school, because if you know your times tables, you should be able to rattle them off fast. Pop quizzes with the clock ticking, national standardized tests where time management is half the battle. Even those math competitions where speed is literally part of the score. The assumption has always been fast equals fluent. Fast means you really know it. But researchers at the Polytechnic University of Madrid wanted to test this. They wanted to know, in the real world of higher education, over the long haul, what actually matters. So they designed a 5-year longitudinal study. That's research speak for they followed the same approach with the same tool, tracking everything for 5 full academic years. The setting was engineering courses, heat engines, thermodynamics, subjects where concepts build on each other, where you can't fake understanding. Where if you miss week 3, week 7 becomes nearly impossible. Over 1,000 students participated across 6 different courses, from bachelor's level through master's programs. And here's what made this study special. Every single week, at the start of every class, the professors used Kahoot to ask 3 to 4 questions reviewing the previous week's material. Not at the end of a class as a reward, not occasionally when there was time, every single week. For formative assessment. That's assessment designed to help you learn, not just test what you know. Now imagine you're a researcher with this massive data set. 5 years, thousands of students, hundreds of thousands of individual quiz responses. You have metrics on everything. How many questions each student answered, how correctly they answered, how fast they responded, how often they attended class, and of course, their final exam scores. So, what's the secret sauce? What predicts who does well? The researchers ran the numbers. They looked at correlations. That's statistical speak for when this goes up, does that go up too? And here's what they found. Consistency was king. Not speed, not getting a perfect score every time. Consistency. The students who showed up regularly and answered more total questions, who stayed engaged week after week, they performed best on final exams. Let me give you a technical finding. 21% of the variance in theory exam scores could be predicted by how consistently students participated in the Kahoot sessions. Now, if you're not a statistics person, you might think 21% doesn't sound like much. But in educational research, where human behavior is complex and influenced by hundreds of variables, 21% is significant. It means that one measurable behavior, consistent engagement, accounted for about a fifth of what determined student success. But here's where it gets even more interesting. The researchers found that Kahoot performance correlated more strongly with theory exams than with numerical problem-solving exams. Why? Because the question formats were similar. They both emphasized conceptual understanding rather than just computational skill. In other words, when students practiced recalling and applying concepts week after week, they got better at recalling and applying concepts. It's not revolutionary, but it is incredibly validating. Here's a crucial detail about the study design. The professors made Kahoot scores worth up to 10% of students' final grades. Now, that wasn't a benefit of using Kahoot. That was a deliberate choice to motivate participation. Students knew they could earn these points by showing up and engaging, which gave them a reason to study a bit more each week. It was just enough incentive to matter, but not enough that you could coast on a Kahoot alone if you didn't understand the material. So we know what worked, but why? This is where we need to zoom out and look at the bigger picture, because the Madrid study isn't alone in its findings. A comprehensive meta-analysis published in the Journal of Computer-Assisted Learning looked at 43 different studies on Kahoot from around the world. We're talking about research from 16 different countries across Europe, Asia, the Middle East, and the Americas. Over 3,300 students total. That's 1,706 to be exact in experimental groups using Kahoot, and the rest 1,647 students in control groups using traditional methods. And when researchers synthesized all of this data, controlling for differences in context, etc., they found something remarkable. Using Kahoot had a moderate to large positive effect on academic achievement, with an effect size of 0.772. Now, in practical terms, that translates to raising a student's performance by approximately 1 full letter grade on a typical test. 1 full letter grade. Or shifting a student from the 50th percentile to the 72nd percentile. But achievement wasn't the only measure. The meta-analysis found an even larger effect on retention. That's how well students remember what they've learned over time. The effect size there was 1.492, which in research terms is considered very large. And motivation, large positive effect, 0.960. Think about that combination. Better achievement, better retention, more motivation. It's not about using technology for technology's sake. It's about creating conditions where learning sticks. So what is it about this approach, regular gamified formative assessment, that works? Let's break down the psychology here. First, There's the spacing effect. This is one of the most robust findings in all of learning science. When you review material repeatedly over time, rather than cramming it all at once, you remember it better and longer. In the Madrid study, students reviewed previous material every single week. That distributed practice is like exercise for your brain's memory systems. Second, there's immediate feedback. When you answer a Kahoot question, you know right away if you got it right. If you're wrong, you see the correct answer immediately, while the question is still fresh in your mind. Compare that to a traditional homework assignment where you might not get the feedback for a week, or an exam where you never see your mistakes explained. The delay kills the learning opportunity. Third, and this is crucial, there is the low-stakes environment. Remember, the Madrid study designed the course so that Kahoot participation was worth up to 10% of the final grade. That's a smart incentive structure, enough to matter and motivate students to prepare each week, but not so much that a single mistake feels catastrophic. The meta-analysis actually found that Kahoot moderately reduced student anxiety, a form of assessment that reduces rather than increases stress. When students can make mistakes without catastrophic consequences, after all, it's just a Kahoot game, they're more willing to engage, to try to take intellectual risks. But there's something else happening here that I think is even more fundamental. The Madrid study spanned 5 years, including the pandemic years. Some of these engineering students were suddenly thrust into remote learning, their lives upended, their routines destroyed. And yet, the pattern held. Weekly Kahoot sessions provided structure, continuity, a predictable rhythm. In a world of chaos, there was this reliable 10-minute ritual at the start of every class. Review, respond, see where you stand. That consistency didn't just help students learn the material, it helped them stay connected to the course, to their classmates, their own progress. So what does all this mean for educators and institutions? Let's start with what it doesn't mean. It doesn't mean that technology solves everything. It doesn't mean you can just drop a Kahoot into a class and watch magic happen. What these studies show is that how you use the tool matters tremendously. The Madrid researchers were deliberate. Same time every week, start of a class, reviewing previous material. They built it into the course structure. Students knew what to expect. And critically, the professors used the data. When a question showed that most students missed a concept, they could address it immediately before moving forward. That's formative assessment in action. Assess, diagnose, adjust, teach. Here's what I find most powerful about these findings. They democratize success. Remember, it wasn't the fastest student who did best. It wasn't necessarily the ones with the strongest prior background. It was the ones who showed up consistently. That's something every student can do. Showing up, engaging, trying. The meta-analysis found that Kahoot had positive effects regardless of the educational level, whether students were in primary school, secondary school, or higher education. Regardless of the subject matter, regardless of which country the study took place in. That's universal. That suggests we're tapping into something fundamental about how humans learn. Of course, there are important nuances. The Madrid study found that Kahoot correlated more strongly with conceptual understanding than with complex problem solving. So it's not a complete solution. Students still need practice with challenging multi-step problems. And the meta-analysis noted that effectiveness depends on factors like careful question design, appropriate time limits, and skilled classroom management. But here's what excites me. We have evidence. Not anecdotes, not hunches, but rigorous peer-reviewed research spanning thousands of students and multiple years. We know what works. Now it's about implementation. Let's zoom out one more time. Education is at an inflection point. We have more research on learning than ever before. We have tools that previous generations of teachers couldn't have imagined. We have the ability to track, measure, and analyze learning at scale. But we also face unprecedented challenges: student disengagement, mental health crisis, achievement gaps, pandemic learning loss. Studies like the ones we've discussed today matter because they give us actionable evidence. They tell us consistency matters more than speed. Regular low-stakes practice beats high-stakes cramming. Engagement and achievement reinforce each other. The Madrid study tracked students through a global pandemic and found that this approach sustained learning even in crisis. That's resilience. The meta-analysis found that this approach reduced anxiety while improving achievement. That's supporting the whole student. And perhaps most importantly, these studies remind us that learning is not a mystery. It's not alchemy. It's a process we can understand, support, and optimize. When we create conditions for consistent engagement, provide immediate feedback, reduce anxiety, and make learning genuinely interactive and even fun, students thrive. Not because they're more talented, not because they're faster, but because we've designed environments that work with how brains actually learn. So here's my challenge to you. Think about consistency in your own context. If you're an educator, what's the one thing you could do weekly that would give students regular, low-stakes practice with immediate feedback? If you're an administrator, how could you support teachers in building these rhythms into their courses? And if you're a student, what's your version of showing up every week? What consistent habits could you build? 1,000 students over 5 years taught us that consistency compounds. Small, regular actions add up to significant results. And if you want to continue this conversation, remember, we'll be at BET in London, January 21st through 23rd, 2026 at the Excel Arena. Come find us. Let's talk about what's working in your context and what challenges you're facing. I'm Meira. This has been Kahoot Impact. Thank you for listening.